isolation levels. And so we spoke about the acid properties, and in particular the isolation property, where the goal is that it looks like each transaction is running in isolation, though in reality there are concurrent transactions going on. So the problem with running with isolation, which is that where you want to guarantee that it looks like every transaction is running in isolation. The problem with that is that you would have to use locks to ensure that no other, so that the output looks, like serializable. And with locks, the performance goes down. So, database, you don't want performance to be down. And so they said, do we really need this kind of such strict serializability? Do we need that for read transactions? As long as the user, on the other hand, is aware that, if you check the airline reservation and you're just reading, it might be possible that what you're seeing when you get down to actually making the booking, you might find that seats that were available have gone. So the idea is that for read transactions, maybe strict serializability is an overkill. So would it be okay if we do something lower? So that's the whole idea. It's really for read transactions. And so we can set the isolation level. So before you start a transaction, so this is the transaction with a bunch of queries, Q1, Q2, Q3, you can set the isolation level. And so there are 4 isolation levels. And so I'm going to start with the one that's right out here, read uncommitted. So in read uncommitted, you have the maximum concurrency, but in terms of about consistency, it is the lowest, because read uncommitted, there are no locks, and you can read at any point in time. So I'm going to do an example. I'll explain with an example. So we'll start with read uncommitted. Now, read uncommitted is like reading stuff which has not been committed. That's what it means, right? So it's like reading dirty reads. So you can also call read uncommitted dirty reads. So so the output for this one, and this I'll show you, is that when you have dirty reads, you can get non-serializable outputs. And you can also get non-atomic outputs. So let's explain this with an example. So we're going to revisit the bank example I did in an earlier class. So we have transaction 1, where someone is moving money from one account to another account. So you have accounts table, and you are transferring $10. So I think the example that we did, so I'm just going to revisit the bank example. Okay, so we have, so we're revisiting that, and the idea is that we have 2 users, user 1. So essentially what you're having is user 1, let's just call it, he's doing transaction 1, which is really updating the accounts table. So just for simplification, I'm going to have, and then you have user T2, who is reading the, or printing, or whatever, the reading accounts. Okay, so we have these 2 users, and for simplicity, let's have the accounts X and Y. So we have, we'll have X is equal to $100 initially, and we'll have Y is equal to 50 initially. Okay, and so we'll just move $10. So we have T1. So let's have T1 is going to be the update one. So we have query Q1, which is X is equal to X minus 10. You have Q2, which is Y is equal to Y plus 10. And then you have Q3, which is either a commit or a rollback. For now, we'll initially start looking at commits, but so that's transaction T1. And then we have transaction T2, which is the reading the account. So this is the one. So we have T2, which is, so let's make it Q1, small q1, lowercase q1, which is print or read, whichever one print X, Q2, print Y. And if you want Q3 commit, it's really, well. So these are the two transactions. And so if you are looking at serializable outputs, you can have either T1 happening first, followed by T2, in which case for X and Y. So let's have X and Y. X would be, if T1 is happening first, so X would be 90 and Y would be 60. Or you can have T2 followed by T1, in which case X and Y would be 100 and 50. So these are the only two serializable outputs you can get. So now we're going to look at what happens if I do transaction T2 has isolation level read uncommitted. So that's like saying if I did, so when I do T2, I'm going to say set transaction isolation level, and I'm going to do read uncommitted. And then you start your transaction. Okay, and then you do Q1 and Q2 and Q3 where you end the transaction. So that's T1. And for T2, that's T2, sorry. And for T1, it's just, it's an update transaction. So the isolation levels do not matter at all. Whenever you update a database, you're going to take hard locks. You're not going to do it. And we are going to do it with a commit. Okay. So now it's read uncommitted. So I just want to show you what are the different orders in which execution can interleave, how the queries could be interleaved, and what the possible outputs are. So on this, I'm going to show the, let's see, the execution order by time. And okay. And here I'll have the output of T2 of the read, So okay, so we have so the standard ones are the serial outputs, where you do Q1, Q2, Q1, and Q2. So that is equivalent to doing, so the output here would be if Q1 and Q2 happen first, you're going to get 90 and 60. So that's equivalent to doing T1 followed by T2. Okay, and then we also have the Q1, Q2, and this is all the commit ones. Okay, so Q2, so this is like 150. Okay, so this was the serializable output, so no issue here. But So this, when you do read uncommitted, the execution are there, that, you know, you can't, you know, I am running T1 and T2 are two different users running on two different machines, and, you know, they could run it in any order. So let's look at some of the other possibilities. So we could also have, let's say we do Q1 first, then you followed by Q1. So I'm showing it in absolute time, and yes, you have Q1 and Q2, so you can visualize two different timelines, but this is the way the execution order, how they were interleaved by time. So you have Q1 and Q1, and then followed by Q2, and then this small Q2. So this one, in terms of execution, you cannot say that T1 happened first followed by T2, nor can you say T2 happened first followed by T1, because they are completely interleaved. So this is a non-serializable execution. You can't. So the question is, what does the output out here look like? If you have Q1 follows, so in dirty reads, what happens is that you read whatever has been updated. So if you have, after Q1, if you look at uh, the small Q1 happens, then it's going to be, I should have done S1, S2 instead of, so we have, oh, sorry. So this has got updated. We have X has got updated to 90 out here. And what about uh, Q2? I mean, out here, this, now that's the thing. So Q2 has happened. So this output is, again, it's 90 and 60. So even though the execution order was non-serializable, the output still looks like T1, T1 happened first, followed by T2. Okay. So here I'm showing an output which looks serializable, but the execution was non-serializable. Okay, and then so that's this one. So now let's look at another option. So the next one is going to be Q1, Q1, and then we have the small Q2 and followed by the large Q2. So again, out here, it's non-serializable because, you know, no one happened. But now let's look at the output. Out here, we're going to have 90. And for Q2, we are going to have 50. So this is, so it's non-serializable on the output because Q1 has happened, but Q2 has not happened. So we have non-serializable. It's also non-atomic because Q1 has happened and Q2 has not happened. So it's also non-atomic. I think I just have to move things here. Okay, so do you understand this output? We have an output which is not serializable and non-atomic. Okay, so that's number 4. So now let's look at the other possible options. So we have, so the next one we have is Q1, Q1, Q2, Q2. So again, this is non-serializable, execution by time. And out here, it's going to be 100. And it's going to be 50. Okay, so out here, it looks like it was T2 happened, T2, T1. So again, so this is an example where the execution was non-serializable, but the output is serializable. Okay, and then the last one is Q1, Q1, Q2, Q2. Okay, so again, this is non-serializable. And the out here, it was going to be 160. So here it's non-serializable, the output. Okay, so do you understand the what I showed when you have the read uncommitted? Read uncommitted is reading whatever changes happened onto the, whatever it sees at that moment, doesn't take any locks, it just grabs whatever. So you can see very inconsistent results. So if you would implement, if you knew that this is what your underlying database system was implementing and you were an application programmer, you would have to really know that and build on top. So if you were writing programs, your programs would be pretty complicated because you have to deal with the fact that it's uh, dirty read. So your results could be very inconsistent. So I hope everyone understood this particular example of what happens when you have read uncommitted or dirty read. Okay. And if you did, so here I was doing the committed. If I had written, if I did T1 has start transaction with rollback. So the only legal result out here is 150. That's the only legal result you should get. Because it's a rollback, it's not doing the update. So anything else that you get, and you can get all of these cases. If you did, when you did dirty read, you could get all of these results. All of you can get either 160, 150, you can get everything in that thing. And when the only one that's a possibility is 150. So that's why you have to, when you use dirty read, you are even picking up stuff that has not happened, that because transaction T1 never went through. So that's the dirty read or read uncommitted. So if you have any questions, just jump in. I'm going to just do another example in the meantime. So we have, so let's, again, when I do examples, I'm going to just look at a very small. So we have a table with just one attribute A and two values, 1 and 2. And we have the following transaction. We have T1. And you have Q2. And then you have a commit. Okay, and then we have transaction T2, which is the read uncommitted transaction. So this is the read isolation level one. So it's read uncommitted. And what you have is just a transaction queue with select A, which is like print A or whatever. So that's all that you have. So, so I'm trying to see, I would like you to try out, but anyway, so I just want to, so after you finish Q1, after this one completes, this is what the table should look like. You're going to have A with 2 and 3. And after this one completes, you should have A with 4 and 6. So that's the one. So again, out here, if you do read uncommitted, the outcome will depend on the order of execution, how things are interleaved. So you can get all kinds of output because it's dirty read. So we could get if you did T2 first, so you did Q followed by Q1, Q2. So this is equivalent to saying T2 followed by T1. Okay, or you could get, so here the, and or you, another one, you could do first Q1, Q2, and Q. So that would be like doing T1 followed by T2. So here, when you have serial in the first case, because you're doing T2 first, you're going to get you're going to get 1 and 2. And here you would get A, 4, and 6. Okay, so those were the easy cases. So I want you to just try out, give me all the so the only non-serializable order is, because you only have one transaction there, is if you did Q1 first, followed by Q, small q, and then Q2. So this is the only non-serializable execution order. So my question to you is, can you just show me all the possible outputs for this? So the first two are, after the commit was done. The second two is Q1, Q, and then Q2. So could you show all possible outputs for, for this one? You could have one or more.
Yeah, it should just be it should be 2 and 3.
Okay, so this is going to be, so we have sorry, we have A, 2, and 3. So this is the case where,
Unless you're talking like the different commits, but if that's for the uncommitted
yeah,
or
so
the
this
read
is,
uncommitted.
okay, so this is the non-serializable. Yeah, it's non-serializable, so don't leave it. Okay, but I do want to say that, okay, this is correct for, in terms of MySQL, this is the only output you could get for 3. This is the one. But I do want to say is that if you had a database that also shows things in the middle where it's non-atomic, so it can show you midway through an operation, you could also get these. So this is the only MySQL. I do want to mention that only MySQL output you're going to get in MySQL. But if you have a database that does non-atomic, you could get the following too. So you could get A, 2, 2. So it's done like midway through the thing and stopped. So,
Okay.
so you could get all of these. So I just want to say that these are possibilities. If you have something 1 and 3, you could get.
With the 1 and 3, would that just mean like you don't? It's not guaranteed what order it updates.
The rows, yeah, remember there's no row ordering in,
Oh, okay. Yep.
yes, so that's the reason. So you could get 4 and 3, and you could get 2 and 6. So these, like I mentioned, these are only possible. You won't get them. You won't see this. You won't see this in MySQL. But these are all the SQL standard. In the SQL standard, all these outputs are possible.
This is for the third example. You could get the 4 and 3, even though the Q only happened after Q1 versus because you have Q2 executing there.
Which one are you talking? 4 and 3. So 4 and 3 happened because it did Q1, but Q2 was done only partly. So it did the first row of Q2, but it didn't do the second row.
Okay, but even though, are you still going off of number 3 here, where you have the small q after Q1 though?
Oh, okay. Yes, that's true. Yeah, I got what you're saying. Is it? Yeah, that's right. Yeah, here, these last two would be, I guess I wouldn't know how to show it. You're right. I didn't notice that. So these two would be for Q1, and then Q and Q2 happening really at the same time, you know,
Okay.
in terms of time.
Yep.
So there's no kind of ordering, like, if you look at the time, it would be like, if you had, you would have, so Q1 is happening anyway. So you have Q1, and then you would have Q2 and Q pretty much happening at the same time. The Yeah, that's the one. I just wanted to, yeah, you're right. I didn't notice that part, but yes, but I just wanted to say that when you do uncommitted read, you can get all kinds of output. In MySQL, this is the only one you would really get through. So did everyone understand this? Do you want, I have to say that at, the ACID properties and isolation levels are really tricky, really tricky. So after I do this, I really, really would like you to try out some of the stuff, play around with it. I have a lab come quiz kind that is there, which is not going to be graded, and I'll put it up. And I really want you to play around with it, because that's the only way you're really going to get this. It is so tricky sometimes. So, so does everyone think they sort of understood read uncommitted? Okay, so now let's look at read committed, the next one. So we're going to look at, okay, so in read committed, the output. So remember, I wrote down out here for read uncommitted that you can get non-serializable outputs and non-atomic outputs. So for read committed, you can get non-serializable outputs, but you only get atomic outputs. You will not get the non-atomic outputs. So we'll go back to the bank example, because that's the one I would like to kind of do for all of these. So we have the bank example. So now I'm going to have user U2, which is T2, is going to be set transaction isolation level read committed, and then I'm going to start transaction. And T1 is a start transaction. Like I've said, T1 is updating. This is only for reads. So let's again look at the outputs. So, let me just, because it's the same outputs as the previous one. So I just want to copy it down. I hope you don't mind that, just one. Let me just bring it down here, because I think I just want to show you the difference with, oh, okay. So here, I've just copied down from the other one. So we have all of these execution sequences are possible. We have all, because that you cannot do. So all of this part is fine. So now what we really have to look out is for this side of it. Whenever you're doing non-serializable, what is the output we're going to get? So I'm going to just remove this part. Okay, so So we have 90, 60, and 150. So now you have Q1. So let's look at this one. So we have Q1, Q1, Q2, and Q2. And it's all on the commit one. Okay, so you're always reading. So read committed means you're always reading the committed database. Okay, so we have when Q1 is reading, so Q1 has happened, so out here. So we always assume that after Q2, the commit has happened. Okay, so assume that wherever we have Q2, the commit has happened immediately after Q2. So there's a commit here, commit is here, commit is here. Okay, so those are the places where the commit has happened. Um, so this one. Okay, so it's all. So you have Q1. So Q1 is going to read the committed data. So it's 100 out here. It's going to read. And then Q2 is happening after the commit. So out here, it's going to be 60. Okay, so did I do something wrong? Q1 is 100 and Q2 happened after the commit. Yeah, so Q1 happened before the commit and Q2 happened after the commit. So it's going to be 160. So then we have the next one, we have Q1, Q1. So Q1 is again before the commit, it's 100. Now Q2 is after the commit, I mean, before the commit, so it's 50. So this is non-serializable. Let me just write down. So this one is T2 followed by T1. Okay, so the next one is again 100 and it's 50. So it's again T2 by T1. And then the last one is again 100. And now Q2s happen after the commit. So it's going to be 60. So it's non-serializable. Okay, so do you see the difference between the previous one and this one is really on, let me just, 1 second. Yeah, so, okay, so if you see out here, I don't know if you can see in this one, you got 90 and 60, while here you got 160. And that's because in the read uncommitted, it read, whatever was uncommitted. But here it only reads what's in the committed database. And at the time Q1 was done, it had not got committed. And then, so the difference between read, they are different. If you look out here, it's different. And here it's different. So there is a difference between read uncommitted and the read committed. In read committed, you're always reading from a data, the committed, whatever is a committed value, that's what you're reading. So in this case, there are fewer cases where you have non-serializable output, and we have no case where we have a non-atomic action. So you have two non-serializable, but all the outputs are atomic. And with rollback, all the outputs will look serial. So T1, look like serial. So it's going to be, you're always going to get 150. You will never see, something that didn't never happen. You're always going to get 150. So all outputs are going to look serial. So do you think you understood this, how read committed works? So let's again look at an example.
I just have one quick
Yeah.
question. I mean, for the one that's unserializable, doesn't it look non-atomic as well? Is that
Which one? Which one?
both of them that are the 160s?
Yeah, so that's the thing. It does, I mean, if you look at them, it's not even about atomic. They look weird because see, atomic means that you did,
All
uh,
or nothing, right?
yeah, all or nothing. But this is not even all or nothing because it should be Q1 and Q2, right?
Yeah.
So it's not that, it's just weird. It's not even non-atomic.
Okay.
Non-atomic is this one, where, this happened, but this did not happen. So Q1 happened, but Q2 did not happen.
Hmm.
But so you do know if it's on one machine, you're guaranteed that Q1 has to happen before Q2. So this one looks like Q1 happened, but Q2 did not happen. So it's actually, I would say it's non-atomic. It's not so much as non-serial as much as non-atomic. You're right. So I could actually, in theory, I could actually write this as non-atomic. That's a good point. Actually, you raised a really good point, actually. So this is not so much as non-serial. This is a non-atomic output.
Okay.
Really. Yeah, so you're right, actually. Thank you for pointing it out. I didn't really notice it. That's why I said this is so tricky, actually. I have to pay so much of attention when doing this. So yes, that's a really good point you raised. So this is a non-atomic output. So on the other hand, this one's really, when you say 160, that's kind of weird. It's like Q1 had not happened, but Q2's happened. So it's like something wrong happened. So that's what I meant, that in the case of read committed, you are never going to get a non-atomic kind of stuff. That is not going to happen. So yeah, thank you very much for raising that. That's a really good point. So did everyone understand his point? It was that this one is really, it's more about a non-atomic. It's not so much non-serial. What happened is that this one shows um, the update x is equal to x minus 10 happening, but it's not showing y is equal to y plus 10 happening. So are there any other observations, questions? Okay, so then let's look at this. Let's do an example on this one. So we have, so let's look at the salaries. Again, I'm going to do a really small table with just one attribute, salary. And I should have just called it A, actually. I don't know why I called it salary. Okay, and then I have transaction T1 is 2 queries Q1, which is update M, set, oh, salary is equal to salary plus 100, and Q2 is a commit. And then I have T2, which is, now this is going to be a read committed. So small q1, I should really call it S1. It's a mistake. When I was writing it down, I didn't realize when I talk, they both are going to sound. So small q1, which is select some salary from M, and small q2 is the same thing. It's going to be okay. So initially, so if you look at this table, initially the sum for the is going to be 30. And then once I update out here, it's going to be salary. It's going to be 110, 120, And then the sum would be 230. Okay, so once T1 is completed, the sum should be 230, and so that's really, and before T1 is done, the sum is 30. So all the possible outputs, so if you look at the outputs, so you could have, what are the, let's see, look at the possibilities that you can have. You can have T1 followed by T2. So that would be Q1, Q2. So here the output is going to, I'll just write down all the cases. So T2, T1. Okay, now we have, let's see, Q1, Q1, Q2, Q2, then you have Q1, Q1. Q2. Don't know if I missed out anything. Q1, 1, 2, 3, 4, 5. Have I missed out anything out here?
The last one you repeated, it should be small q in the middle there, and then Q2.
Okay, okay, so Q2 and Q2. Okay, you said
And now into small q's in the middle, Q1, then small q, and then Q2 is the last one.
those are all the possibilities that you can have. This is the execution orders. So these are all the execution orders. So let's look at the output that you can have when it's read committed. Okay, so all the read committed. So we can have, so T1 and T2, you're always going to get 230 and 230. So T2 and T1 is 30 and 30. Okay, so now this is read committed. So we have Q1. So let's look at this next case. So what do you think the output for this one is? I'm just going, if somebody can call it out, I'll write it down. So for this next one, what will it be? Number 3, anyone?
Should be 30 and then 230.
Yes. 30 and 230 because it's reading. So we're going to assume that the commit is happening at all of these points. Okay, so commit. These are all commit points. Oh yeah, that is commit. So sorry, I didn't notice it was commit. I thought those are anyway commit. So you're right. Okay, and then what are the other? Let's see. And then the next one, anyone? Just give me the output for the next one.
Same as above 30 and then 230.
30 and 230. And then the next one is 30. And so what about this one? 30.
30.
Yeah, 30. And the last one would also be 30 and 30. Okay, so we only have one output out here, which is non-serial. That is this one. I hope I did this correctly because like I said, it's not. So the only one that is non-serial is the output, I mean. All the others, I mean, this one and this one. All the others are the 230, 230 or 30, 30. So everything shows up as 30, 30. So does this look correct? And, because like I said, I was just following what someone else said. I didn't really pay that much attention, but this is what the outputs will look like. And these are all so these are the only 2 serial execution. These are all the last 4. These are all non-serial executions. Only the first two are serial executions, but if you look at the output, only two of the outputs are showing non-serializability. If you look at the rest of the outputs, all of these outputs look like it was T2, T1, T2, T1. So these two are non-serial. Okay, so, and with a rollback, if you did a rollback, do you think you could get any um, non-serial outputs? So if instead of, if T1, a rollback, then all the outputs will be would be like, I mean, all outputs would be serial. All outputs are going to be 30, 30, because rollback you're never going to see. So I would, as an exercise, you should try the same example and try it with read uncommitted. What are the different possibilities you can get with read uncommitted? Okay, so does anyone have any questions or anything? I mean, do you kind of get this? Okay, so the key thing is read uncommitted reads whatever is there, has been done. It doesn't matter whether it's committed or not. It'll grab whatever has happened, it'll grab it and pick it up. That's read uncommitted. It's called dirty read. So if you are running a transaction with the dirty read, you might see things that never happen because there could be transactions that roll back, it crashed and roll back or roll back, and you would see stuff that might never have happened. So that is the read uncommitted. There are no locks, it grabs everything. And then you have read committed. In read committed, you're always reading whatever has been committed to the database. So in this case, you might see non-serializability like we saw in this particular example, where we have, one query Q1 happening, you know, before the commit. So, I mean, so this one happened before the T1 committed, and this one happened after T1 committed. And same thing out here. This Q1 happened before um, T1 committed, and this happened after T1 committed. So you can still see non-serializability, but you will never see non-atomic. So the third option, if you look at the isolation levels, is something called repeatable read. So that I will be doing on Friday, but I just want to kind of just give you an idea of repeatable read. So repeatable read is the default level in MySQL. So in all these things that you've been running so far, if you don't specify the isolation level, it is going to be repeatable read. So the thing with repeatable read is that the output looks serializable and the output is always atomic. So that's wonderful. You're always going to get serializable output and atomic output. So I'm not talking about the execution. Like I've always been telling you, execution can be interleaved. So that's what I showed out here. The execution can always be interleaved, but it's about the output that you look at. So in repeatable read, the execution can be interleaved, but the output will always look serializable and it will always look atomic. So it's wonderful. And that's why it's a default level, except for one tricky thing called phantom reads. So there's always some kind of, you know, something that messes things up a little bit, which makes things complicated. So the complicated part for repeatable reads are this thing called phantom reads. So anyway, I'll do that in class on Friday, and yeah, that's it. So Any questions or anything? And I will be putting up the the lab come quiz or whatever. And I wouldn't mind if you, I mean, if you get the time, just kind